All right. Let's review the tougher of factoring. We reviewed greatest common factor and difference of perfect squares. Well, there's some expressions where there is no greatest common factor, like this one, and it's not the difference of perfect squares. So the only way we can unmultiply it, in other words, this quadratic was created by multiplying two linear factors. You remember how to do this one? What's the first step?
Is it like the x and then the plus 10 and then the x and the other one and then plus 25?
No. Well, first of all, let's go through these step by step. These are hard, and if you can remember the steps, then you can do any of them. The first step is to split apart the x squared. Okay, well, that's got to be x and x. In other words, x times x is the first step of FOILing, and that would give us x squared. Second step is to figure out the signs, both of them, that are going to follow the x's. So what must the signs be? We got
Positive.
They can either be plus minus, plus plus, or minus minus.
Plus plus.
Yeah, and the reason I'm basing that is this plus sign right here, the one that's in front of the number. Remember, the last step of FOIL is going to be to multiply this number times this number, and the only way we can produce a plus is if these two signs are the same. They don't have to both be plus, they could both be minus. But to determine, this says they're the same, and this one says they're both plus. So you have to look at both the signs of the constant term and the signs on the middle term. Very important when factoring. Now, that's steps 1 and 2. Splitting apart the x's and figuring out what both signs are. Step 3. I'll verbalize it.
Put the 10x. Okay.
It helps if you could verbalize it. If you could remember how to verbalize it, you'll remember it better. So here's what we're looking for. We're looking for factors of 25, that is, two numbers that multiply to 25, and add, because of that, to 10. Well,
5 and 5.
And that's on these kind of problems. This is as simple as it gets. There's only 3 steps. And those are the 3 of them. Okay? Now, let's go back and change that plus 10 to a minus 10. Now, what is step 2? What are the signs? This says they have to be the same.
Minus minus.
And again, we're looking for factors of 25 that add to the number 10. Not to the number negative 10, but just to the number 10. Well, again, 5 and 5. So that would factor like this. Okay? All right, now let's try harder ones. The next degree of difficulty is when that is a negative sign. Okay, let's try this one. Steps 1 and 2 are still the same. What goes here and here?
The x.
What are my signs?
Subtraction.
Both signs. Remember, step 2 is to find both signs, not just one. How can I produce a negative right there? Both signs must be opposite.
Have one adding and one subtracting.
Yeah, that's the only way it can be. In other words, if they were the same, if this was plus plus or minus minus, then this would have to be a plus. Remember the fourth step of FOIL. You're multiplying that number times that number. So the fact that we have a negative in front of the constant means that both signs had to be opposite. And opposite in this case, it doesn't matter whether I put the negative there and the plus there, or the plus here and the negative there. In this case only, dealing with these elementary quadratics. Okay? Now, the third step is a little different. No, excuse me, the third step is actually the same. And it is factors of 10 that subtract, not add, but subtract to the number 3. Well, what would that be? What are factors of
5 and 2.
Yeah, so those are our numbers. Now there's a fourth step. When there's a negative sign over here, there's a fourth step. You have to figure out where to put the 5 and where to put the 2. One goes there, one goes there, but which one goes where? Well, here's the rule. Take the larger of your factor, 5, and put it with the sign of the middle term. The middle term is negative, so the 5 goes right there. The only other place for the 2 is right there. Now, whenever you have factored an expression, the one thing you should always be thinking about is, does this multiply together again to give me that? Well, let's do it. It's x squared minus 5x plus 2x minus 10. Okay? Notice that there's only one of those anywhere, and there's only one constant anywhere. But the two middle terms always have to be combined. Well, if I take minus 5x and plus 2x, I get minus 3x. So my final answer after foiling them is this. Same thing. So I did it correctly. Okay?
Okay.
However, you don't have to go to all that trouble. You don't have to FOIL the whole thing. By the way that I factored this, I know that x and x multiply to x squared. So I'm not worried about this term being correct. I'm also not worried about this term being correct. My third step was factors of 10. That guarantees that's going to be correct. The difficult part is the middle term. Does this produce this middle term? Well, the middle term is always produced by the insides being multiplied and the outsides being multiplied. So I like to do what I call double smiley face check. And you'll need to do this check as we get harder problems. In other words, as we go up to the second level of difficulty, you have to do this check to solve the problem. It becomes harder. Okay, well, that's what those two add to, and that's our middle term. So I was able to check it much easier than by foiling the entire thing out.
Yeah.
Okay, let's do another one with a negative sign. Work me through all 3 steps. All 4 steps, actually.
So put the x in each parentheses.
Step 1.
And then plus and minus.
Step 2. Verbalize step 3 for me.
find factors of 12 that add up to the middle number.
Factors of 12 that subtract, not add. Subtract because of that negative sign.
Okay.
That subtract to the coefficient of the middle term. So verbalize it again. Factors of 12 that do what?
That subtract to the coefficient of the term.
Which is what? What number is that?
1.
Okay. So here's all the factors of 12. If I do it the hard way. Which factors subtract to the number 1?
Three and 4.
Where's the 4 go? Where's the 3 go? That's step 4.
The 4 goes in the front.
With the plus sign. 3 goes with the minus sign. Good. So you can tell that when there's a negative sign here, there's 4 steps instead of 3 steps. If this is a positive sign, then these are very easy. There's just 3 simple steps and it's not hard at all. The negative sign tends to make them a little different. In other words, it adds that final step where you not only have to come up with the factors, but you have to figure out which one goes with the plus, which one goes with the minus. Okay, I'll do step 1 for you. Ooh, what was that? Step 2.
Subtraction and addition.
So plus minus. And step 3. Verbalize it.
Then find the factors of 12 that subtract to the coefficient.
Okay, so tell me what that number is. In other words, when I say verbalize it, what I'd like to hear is factors of 12 that subtract to the number 4. And not to negative 4, but
okay,
just to this number. In the last problem, this number was a hidden 1. But in this problem, it's very clearly 4. So which factors of 12 subtract to 4?
6 and 2.
Okay, where's the 6 go? Which sign does the 6 go with? Which sign does the 2 go with?
The 6 goes with the plus.
Remember, the larger factor always goes with the sign of the middle. So the 6 goes with the...
Oh, okay.
Okay. These 2 signs, this one and this one, determine everything about how you're going to factor this. Notice that this one determined step 2 and step 3, and this one determined step 4. So these 2 signs are very, very important. Distinguish between them. One is the sign of the constant, one is the sign of the middle term. All right. Factor this for me. Now, what's the first step in factoring?
What do you mean?
What's the very first thing you have to do when you look at a factoring problem? You have to see if there is a greatest common factor. You always want to do that before you split it into parentheses. So is there a greatest common factor here?
8.
Remember, the greatest common factor has to divide into every term evenly. 8 does
2.
not divide into 2, but 2 does divide into 2, 8, and 24. So I can take a 2 out. What's left over?
X squared.
I'm taking a 2 out of every term.
6.
What's 8 divided by 2?
Oh, 4.
Now, as I'm doing this, I'm double checking to make sure I'm right. In other words, when I did that, I made sure that it was equal to that. When I do this, I'm making sure that it's equal to that. Remember, you don't want to change the value of anything, because all you're doing is basically unmultiplying this. This started as a bunch of linear things, and you're multiplying them together, and now we're learning how to go the other direction. What's this last term?
12.
Okay. Now, notice what we have. Now we have this that can also be factored, and we need to. In other words, taking out the greatest common factor left us with a simple quadratic. So I still need to have that 2. This one we just did. Factors of 12 that subtract to 4. That's 6 and 2. Only this time the 6 goes with the plus sign, because the sign of the middle term is plus. So this is our final answer. Okay? So always remember there's kind of an order. Always look for greatest common factor first.
Okay.
How would I do this beast? Is there a greatest common factor?
No.
X.
X.
Notice that every term can be divided by x. I can divide that by x, I can divide that by x, I can divide that by x, and I'm left with a whole number, or some number of x's. Okay, so I want to take the x's out. Now, your first clue here is that at no time in the next year or two are you ever going to have to factor what are called cubics. So if you see a x cubed, you know immediately that you must be able to take an x out of that. Because once I factor out the x, what do I have left?
X squared.
Remember, you're always dividing every term in the expression by x.
And then plus X. And then minus 12.
Good. Now we're looking at another standard quadratic that we can factor. Factor that again.
X in each of them. And then plus and minus. And then factors of 12 that subtract into X.
Not to x.
Or 1.
To 1. Good. Very good.
1.
What are those two numbers?
3 and 4.
And where's the 4 go? The bigger number?
With the plus.
With the plus, the sign of the middle term. So the 4 goes there, the 3 goes there, and again we're done. Now, let's go back and figure out why this is so valuable. Let's say that we had an equation at the beginning. Well, solving that is really hard. I've got the sum and difference of three terms equaling 0, what the heck can I do? Well, by the time I've fully factored it down to here, and if all of that is equal to 0, now I'm in good shape to solve it. What are my three solutions for x? And incidentally, you almost always have the same number of solutions as you have that. In other words, a cubic always has three solutions. A quadratic, where that's a squared, has two solutions, and so forth. A quartic, where it would be x to the fourth, that's going to have four solutions. So what are my three solutions here? Remember, I've got three things being multiplied together that are equal 0. So the way you solve it is you set each of the three things to 0 and solve it. So, first solution's pretty obvious. X could be 0. Right? I mean, if you go back up here, you plug in 0 for x, you notice you get 0 plus 0 minus 0. That does indeed equal 0. Second solution, I'm going to take this quantity and set it equal to 0, and then solve, which means x equals minus 4. There's my second solution. And finally, I'm going to take the third quantity, set it equal to 0, x minus 3 equals 0, which means x equals 3. So those are my three solutions. X could be either 0, x can be minus 4, or x can be 3. Did you lose audio for a moment? You still there?
Yes, I did.
Okay.
I lost audio.
You did lose audio?
Yes.
I thought I heard a little blip, which usually, and I heard it again. You still there?
Yes.
Okay. All right. So that's why factoring is so important, is because it allows us to solve equations. Now, you say to yourself, well, what if this side over here is not 0? Let's go back. Make the problem look like this.
My screen is frozen.
Your screen is frozen.
Like what you just wrote.
Yeah, let me open up my meeting and see if I can figure out. Yeah, it says you're offline. Can you log out and log back in? Let's see if we can figure out how to fix this real quick.
Okay, yeah.
Log out of your GoToMeeting by clicking on the X at the upper right, and then just log back in, and I'll leave the same meeting ID number that I texted.
Okay.
We'll see if that helps. Back? Jana? Hello? Okay, you're back.
Yes.
Okay. Interestingly enough, my GoToMeeting thing shows you in here twice. But now one of them went offline. You still there?
Yeah.
Okay, cool. All right, so back to our problem. In other words, the whole point of learning factoring is to be able to solve problems. You end up with a lot of real-world problems where you have equations like this, and you need to solve them. Well, if it's not equal to 0, we move this constant to the other side by subtracting 12 from both sides so that we always make it equal to 0. Whatever is over there, we want to get rid of and turn it into an equation where one side is the quadratic and the other side is 0. And then we factor this into x minus 3 times x minus 4, or x plus 4. And now this one only has two solutions, which are going to be x equals 3 or x equals minus 4. The third solution, x equaling 0, no longer works. It's not one of the solutions. This is a different problem than what we were just doing. So, okay. That's factoring in a nutshell. Always look for greatest common factor. Wow, my GoToMeeting is switching back and forth between the two Jennas. You're back now? You still there? All right. You back?
Yeah, sorry. It keeps reaching out.
I wonder what's going on your end. Let's see. Your iPad, is it an iPad?
Yeah.
It's connected to the Wi-Fi in your house?
Yeah.
It's using the Wi-Fi in your house, yeah.
Yeah.
I don't know what might be going on, but we're at the end of the session, basically. Let's do one more problem before I let you go.
Okay.
Regarding factoring again, and that is simplifying radicals, like that. Did you have to do this at all in school?
I can't see what you wrote.
Frozen. You're both offline. We'll just end it here, and we'll pick up again Monday morning.
All right.
Okay? That's okay. We may have to do, I'm not sure how we're going to solve this problem. Hopefully we won't have it Monday morning.
Yeah.
But I'll talk to you then.
Okay.
All right. Bye-bye.